So what does it mean for you in your day-to-day job, your private life maybe, to have a green mind?
Oh, wow.
It's a big question, I know.
It is big. I would say the very first thing is
Fadi Alshakhshir is one of the region's most influential voices in facilities management, authored the first book on energy-centered maintenance in the Middle East, and now lectures the next generation of engineers at Heriot-Watt. His work cuts millions in energy waste, transforms mega asset operations, and redefines FM as a strategic function.
I would say the very first thing is to have an open mind. Sustainability or green supporting initiatives is not a single person effort, and it will never be.
It is more than just changing the light bulb. It is a lot more than that.
He needs to be really open-minded and be able to bring all these people together around the same objective.
Welcome, Fadi.
Thank you, Walewein.
It's good to have you as my guest, and actually honored because you've just published a book, AI-driven energy-centered maintenance, and it's actually the third edition already. Very interesting read. The AI component, obviously, something to look at, but you're bringing basically a couple of things together that I think are very, very key. How you integrate data analytics, AI, machine learning in effectively improving your entire maintenance whilst being focused on energy measurements as the core of things. Why did you actually write the book?
Thank you so much, Walewein, first of all, for having me. It's actually my honor to be here with you. The book story goes back to 2016, and that's when I first started writing the first edition of the book. And in 2021, I published the second edition, and recently I published the third edition. The idea came from my car in 2016. Okay. So I was driving a car, and the average oil consumption in my car was around 10 liters for every 100 kilometers of distance. And by time I noticed that the oil consumption is increasing, and it reached around 11.5 liters for the same distance. And at that time I was looking at the car. The car is reliable. The car is very well. I have no issues with it whatsoever, but the oil consumption is increasing. Then I said, okay, I will leave it as it is. And the next maintenance cycle at the agency will look at it and they will fix it. And I sent it to the agency for normal maintenance. And when I got my car back, I noticed that the consumption remained at 11 or 11.5 liters per 100 kilometers. So it did not really, the normal maintenance did not really enhance the energy efficiency of the car. So I asked the supervisor at that time, we did the maintenance, why the consumption is still increased or higher compared to what it should be. And he said, well, this is a different issue. There is a different team who will look at that matter, because this team, they have a different skill set, and this team, we need to raise a job card for it, and we send it to them. And you need to pay, of course, a small amount of money for that inspection and all of that stuff. We've done that. They found the issue. They fixed the car. So then when I received it back, I started thinking about the way that we are maintaining our facilities. And in the maintenance science, reliability-centered maintenance is the most, I would say, advanced maintenance strategy. But when I looked at it from an energy perspective, we're not actually maintaining the equipments to be energy efficient. We are maintaining the equipments to be reliable. Then I thought, okay, I need to write something that as we maintain it for reliability, we also need to maintain the equipments in our facilities to be energy efficient all the time. So at that time, I looked at different industries, energy management and energy audit in one side, and the maintenance management on the other side. And I integrated both together in a new book or a new maintenance model called energy-centered maintenance, which means that the maintenance activities, when it's done, it will be centered now around improving the energy efficiency of the equipment. And that was the first edition. That was a manual process. So people go to the machine and they inspect the energy performance of the machine. So they look at the motor consumption, they look at the pressure drop across the coils, they look at the temperature difference and different factors, which are mentioned in the book. And they do the necessary adjustments according to the results. And that was time consuming because people need to go physically and do these inspections. In 2021, when the IoT devices became available at reasonable prices, I wrote the second edition, which is the data-driven energy-centered maintenance. And that's where, when we implemented it, we started receiving a big amount of data. And we had data analysts to analyze this data and to help the technicians on doing the right thing.
Yeah.
And when the AI era came in recently, I thought, okay, it's now time to go for machine learning and artificial intelligence. And the AI model that we build now in the facilities is the one who's doing the analysis of these IoT devices.
So basically, it is bringing together technologies that are there, but also at the same time looking at some of the practices that go alongside with it. When you look at today's developments, and AI being obviously front of mind at the moment because a lot of people are talking about it, writing about it. Like you say, IoT is already there for a little while, becomes more affordable also. Do you have any examples here in the region where you think those guys have it right? They already execute quite nicely what I'm writing about here in the book.
We do actually. We have case studies that are implemented in Dubai. The model is implemented in residential buildings. It's implemented in commercial buildings like malls, and recently it started implementing it in entertainment attractions. If anyone would like to read about the topic itself, it's now also extended to manufacturing. And that was something that I was amazed to see some industries other than facility and energy management, which is the manufacturing industry, started implementing energy-centered maintenance as part of their maintenance regime and writing about it. So the information are available. The case studies is actually important for validation. So that was one of the main reasons that it's time now to publish the next edition. So the way I publish the editions is actually after implementing it for a while and getting the information, validating it, and then publishing it for the audience.
Yeah, because that I think is probably also one of the big hurdles for people to really start investing in it. Because I figure if you want to move towards an AI-driven maintenance strategy and centered around energy, there's a lot of investment required, I guess. Or
look, in Dubai, the good thing is that the buildings are modern. And the buildings pretty much equipped with enough, and the equipment equipped with enough meters or IoT devices that can provide foundation for the AI-driven energy-centered maintenance. The investment will be in the software part, not the hardware part, not much in the hardware part. So there is an assessment, a gap analysis that needs to be done before implementing it to understand what are the cost implications of implementing it. Because if an investment is required, definitely there should be some sort of payback period for the investor. And that's also covered in the book, how the investor or the organization can calculate their investment cost and how much is the ROI that they can get in terms of energy cost reduction. I did not touch much on the software cost for a very simple reason. Many companies nowadays like the international BMS companies that are available around the world, they provide that service, the analytical part, which is through AI, as a cost sharing sort of thing. So it's like a software that some sort of subscription.
Yeah.
They call it SaaS kind of models.
Yes.
So that's a risk-free for the organizations in terms of an investment, because there is no upfront investment that is needed. There is some sort of shared saving with these companies who are utilizing their IoT platforms and AI platforms for implementing it.
But when you look at companies, basically here, we are talking about the UAE predominantly, but I guess in the Middle East and especially in countries like Saudi also, where there's a lot of development going on. Would you see an approach to be successful in implementing an energy-centered maintenance strategy as a project, or is it really something that requires an overhaul in how an organization is organized?
It's a combination of both. It's a strategic approach. It's not a normal maintenance regime. Normal maintenance regimes comes from OEMs, from the equipment manufacturer themselves, or by experience when we adjust our maintenance requirements based on the actual operating parameters of the facility. Energy-centered maintenance it's changing the shift from being focused only on reliability to both achieving reliable equipment and energy efficient equipment. Of course, it's always better to equip the equipment with the right sensors and the right meters during construction. It's easier, and it's, I think, economically more affordable comparing to retrofitting later. So my recommendations for any new project is to look at what are the minimum sensors or IoT devices that needs to be installed within the equipment to have the best energy performance monitoring. And based on that data, we can adjust our maintenance regimes to ensure that energy consumption is always met, or energy efficiency is always met.
So if a company embarks on that road where it says, okay, energy is going to be really central to my maintenance strategy going forward, what sort of like the blueprint, where do they start? What do they need to have minimum?
Okay, two things. They need to have the right, as I said, components to monitor the critical energy related patterns. And this is quite tricky because people sometimes think that energy is only monitored by electrical consumption, which is not true. I mean, electrical consumption obviously is the result of other energy related parameters. So flow rate is something that needs to be monitored. Differential pressure needs to be monitored. Difference in temperature needs to be monitored. All these aspects together can give an indication about the energy performance of the machine. And ultimately, the result is either increase in energy consumption or decrease. So these measurements can be done manually through an energy auditor, and that will be at a certain time, or the equipment should be equipped with these meters to give you an continuous data about the energy performance. So that's one thing needs to be implemented. The other thing is the skill level of the technicians or the maintenance professionals who are conducting the maintenance. And that was one of the challenges that we faced while implementing energy-centered maintenance for the first time. Because similar to the car situation, there is a certain skill set that is set for maintaining reliability of the car or the equipment. If we wanted to increase the energy efficiency of the car, it had to go to another team who are skilled for that particular purpose or objective. In energy-centered maintenance, it's the same maintenance team who should be capable of monitoring the energy performance of the machine. It's not an energy auditor that needs to come and do it. So the level, in terms of educational level or practical competency of the maintenance team needs to be increased, and they need to be educated to become some sort of an energy auditor at the same. So they are maintenance professionals, and at the same time they can monitor the energy-related patterns of the equipment.
Do you see that as a hurdle in the market here, or?
For a certain extent, yes. It depends on the requirements of the organization. I was lucky that wherever this model was implemented, the organizations, whether it is the developer or the client side or the facility management company who implemented it, were interested in bringing up the level of the staff to that level. But if you go to another organization who might not be interested in that, that will be definitely a challenge, because training is key for these skilled technicians to become also skilled in energy-centered maintenance.
Yeah, because what we see a lot is that when you talk about, and we'll talk a little bit more about HVAC in a bit, but when you talk about HVAC maintenance, a lot of people are still only focused on give me a before and after picture of whatever it is that you've done, but it doesn't tell you any story really at the end of the day. And with a few simple measurements before and after, you can actually come up with a story that is a lot more reliable already around that unit, how it was performing and how it is now performing in basically the clean state or cleaner state. Would you feel that it is actually mandatory for any company that is serious that they have to invest basically in training their staff, in making sure that they can do some simple measurements before and after prior to investing in, if they have to, retrofitting all their equipment with the sensors and IoT solutions?
It is. And actually it is required not for the sake of what maintenance model is required. It is required if you have really the green mindset in the organization. I mean, a simple reference is the green building certificates. Now, one of the main requirements for them is what's called continuous commissioning. So previously it used to be a retro commissioning. So you do a retro commissioning for one time, and then these are the results before and after. Now the requirement is continuous commissioning. Continuous commissioning means what? It means that you need to keep your eye on the parameter of the machine continuously. So that can be achieved by either having continuous commissioning, like periodic one, or to have a live data giving performance parameters like from the machine itself to show us what kind of commissioning is happening at the moment, or what is the current result of the performance of the machine at the moment.
Yeah, and I think also that you'll start to recognize also when you measure a couple of KPIs around a unit, that each unit sort of has different behavior. I mean, a lot of maintenance is still being done on a scheduled basis, or worse, when something breaks, we do something. But every unit has its own sort of life and behavior. Like your example with the car, I mean, your car started consuming more oil, but that doesn't mean that the next car has the same sort of behavior per se.
Correct.
When an organization decides to go on to this route for all the good reasons, because we want to become more sustainable and we want to conserve energy and we want to be optimized really in it also, and you want to move to predictive maintenance, what does that mean for an organization to become predictive?
Interesting, because predictive maintenance, I would say, is the ultimate goal. And it depends on trends, basically. So if I go back to the example of the picture before and after, that's one time maybe some sort of evidence of what kind of breakdown was the issue and how it was resolved. But it doesn't really give trend. So and that's again why some sort of IoT devices are required to monitor the parameters and to give a trend. And based on that trend, the AI model can predict whether there is a potential failure that could happen or a change in the energy performance of the machine that could happen. And it can give an indication ahead of time to fix that issue before it actually happens. In my opinion, depending slowly on predictive maintenance is required. But at the same time, there are regulatory requirements that needs to be met. So if we take an example of an air handling unit that needs to be maintained monthly, maybe if we depend on predictive maintenance, that can be maintained on a longer period based on the performance of the machine. And that's what AI-driven energy-centered maintenance is actually focused around. But let's say that the machine was running for 3 or 4 months without any issues. For regulatory compliance requirements, maybe the machine needs to be maintained still at this time, although it does not give any indication for any performance issues. That's maybe not applicable in the full HVAC system, but in firefighting, it's required. In electrical, it's required.
Yeah, and that is obvious. You need to marry all those different requirements into. But I guess also when you look at the power that machine learning and AI will give, you can bring those parameters together, and the system will become smart at some point in time, correlating these elements. And I guess also at the same time, it is different from industry to industry, because whether you are maintaining a residential complex or you're maintaining a hospital complex or a factory, those are all very different use cases, I would think. When you look at HVAC in particular, because there is a lot of information, focus on HVAC, it being obviously the largest consumer in our buildings. What sort of are the key KPIs that you believe drive ultimately becoming predictive in energy centered maintenance?
Very interesting. And before I answer the question, I'll tell you just that the utilization of AI in this particular book and in other industries like in energy management and all of that stuff, the advantage that we can see immediately, that the prediction of the what's going on or what could happen in terms of maintenance has increased compared to data-driven analysis, the normal data-driven analysis. So that's an advantage. So now we're talking about an accuracy of prediction between 80 to 85%, which for sure by time will be more as the machine keeps learning by itself. These predictions are based on the information that are received from the facility itself. And as you said, whether that's industrial or it's commercial facility, which leads into a very important point, that are these devices giving the right information or not? Because we're talking about IoT devices, which means that these IoT devices should be either calibrated regularly or maintained in a way or another to ensure that it's giving you the right information so the machine can predict based on actual figures. Now, in terms of KPIs, what we look at is very simple, is the performance parameters of the machine. The one that we based our book about is the original testing and commissioning data. So again, the car, it's the original accepted consumption of oil, and how close we are getting to that particular figure. Now, there will be, and I would say easily you can go to 95% of that value. Maybe there is a 5% that cannot be achieved because of aging. That happens. Or maybe that if you want to hit 100% accuracy, maybe the investment will be not reasonable at that point of time. So the facility manager, alongside the energy manager of the facility, they need to sit together to decide what is an acceptable performance of the machine that we say, okay, this is what we need to achieve. And that's what we are writing it in terms of KPIs. It can be related to consumption, it can be related to investment cost, it can be related to original testing and commissioning data that we need to reach, how close we need to reach to this original data.
Yeah, and I guess also the purpose of the building drives a big part of that also. Like we said, I mean, a hospital may have a different outcome requirement than a commercial building or a residential building. Hotels have the same. When I look at the HVAC stack, which is more than just the air handling units and the FCUs that are there, it's connected to either district cooling or it's connected to your own chiller plant. What sort of do you think these type of models will help give the organization in helping them to get a clear picture on the whole as such? Because again, if you're fragmented in your approach, your outcome may not be as impressive as when you see the full picture.
That's absolutely right. And this is one of the things that I keep asking about when, for example, I get a proposal to change the parking light to more energy efficient, and then we get that you will get 30% reduction in savings. Then when I ask, okay, how much is that from the overall consumption of the facility? The approach in the energy-centered maintenance, it's to integrate it in day-to-day operation. So, and that's why we called it maintenance. It's not energy management, energy audit. Energy audit can be done once, maybe if it's a level 1 audit once every year, and maybe if it's energy level 3 audit, it can be done every 4 or 5 years. And what we get at that time, recommendations to improve this holistic system, as you mentioned, and to improve the energy efficiency of it. And these recommendations gets implemented. The energy consumption goes down, so it improves. And by time, when the energy management company leaves the site, the energy consumption starts increasing slowly to its original or previous consumption. And the reason for that it was not integrated with the day-to-day operation. So what is the most day-to-day operation that we have in facility is maintenance. It's very clear. So integrating the energy efficiency of that overall system and as part of the maintenance regime is the solution to maintain that continuously.
But that's quite complicated in a way, or complex, I would say. Complicated, maybe not, but complex to implement it in a very efficient manner, because there are so many stakeholders involved ultimately in that maintenance topic. It is the owner, the asset manager maybe, or sometimes the owner, the operator, sometimes a third party that is involved. So how do you bring all that sort of on the same page?
This was also a challenge at the beginning, but what we did and what we ended with. What we did before implementing it, we all sat together around the table, and we put together what is our ultimate objective, all of us, and it was very clear: reliable machine and that satisfies the owner, with an energy efficient consumption, satisfaction as well, and lower maintenance cost. And I have to say, people eventually want to have some sort of financial appraisal or objective at the end, which is something I understand.
Money talks.
Yeah, exactly. So based on that, we put our plan together in the very first time that we did it. And there was some sort of an open mind perspective from each of these stakeholders. So the facility management company, they were looking at it that this is a good training tool for their staff. At that, if you remember, Walewein, a few years ago, I would say maybe 10 or 15 years ago, when we used to receive the submissions for facility management contracts, the good facility management companies were saying, we have a value add in our contract that we will conduct an energy audit for you through our subsidiary, which is an energy management company, at free of cost. And that was really for us attractive as client representatives. Okay, this is an added value compared to compliance of the scope of work. Nowadays, this became normal. If you don't conduct an energy audit as an FM organization,
You discount it.
I mean, that's exactly, it's no longer an added value. It's now, that's the best practice to be done. So at that time, when we started implementing it, these companies were really interested in that added value to their staff and to their client, to train them to include that in day-to-day operation.
Yeah.
So we were trying to balance all these things, and we were successful in doing it.
Yeah. Yeah, and I think coming back to the role ultimately on the floor of the technician in the execution of the maintenance work, your point earlier about making sure that these people are trained properly, they understand, is actually an enriching value for them as well. I mean, because if you look at some of the maintenance work, it is very repetitive, not necessarily the most beautiful thing to have to do. And nobody at the end of the day wants to do a bad job. They want to do a good job. And so that's quite important. When a company sets itself a target, for example, we need to save 10% on our energy consumption next year, which typically is a daunting task, I would say. What would be your biggest recommendation for them to start working on now to get there?
Okay, 10% I would say is not a big target. I think organizations should hit 30-40% ambition at least.
Okay.
And by the way, we're heading towards net zero by 2040.
That's
so
the point.
obviously we need to do we need to do something about it. I believe that 7 to 10% can be achieved by only looking at the operating profile of the facility, which is very, as we call it, low-hanging fruits or no-cost energy conservation measures. These companies need to conduct an energy audit around their facility and to look at the energy performance of the machines and to look at their maintenance records. If their machines are not maintained properly, there is a chance that the energy consumption of these machines is high compared to typical equipment. If the machines are left operating 24/7 for no reason, obviously it will end up by increasing energy consumption. I always say in energy management there is supply side and there is demand side. I always say that you need to reduce the energy consumption in the demand side as much as possible by eliminating any excessive energy consumption that is not required, by implementing the latest technologies where that is financially feasible for the business to reduce the energy consumption. And when you reach this is the minimum that we can operate on, we start looking at the supply side and we start maybe having some sort of solar panels to cover 5% of that consumption with that facility, or following the rules here, I mean, or maybe it could be more in case there is a sort of partnership. So it's balancing both the supply side and the demand side, and starting with what are we doing now in our facility? Let's get the experts, walk around, tell us what's going on. And there might be some requirements for changing design. There might be some requirements for changing equipment, as long as it's financially acceptable and that some sort of financial analysis is done properly. I'm sure these organizations will implement it. The industry has evolved also over time. Previously, we used to do these investments ourselves as developers, and we implement some sort of energy conservation measures. Now there are energy saving companies, the ESCOs, who can go for shared saving schemes. So the investment itself is no longer an issue. Even if a certain client does not want to do that investment, there are companies who are interested to do that, and they will obviously share the savings with the client to recover their costs. So it all goes around, are we really open-minded for that change or not?
Yeah. And that is right. I mean, I guess that ultimately it's all about sharing the gain at the end of the day. When you look at the region and we look at the technological solutions that are available to us today, which do you think are underused and which do you think are overhyped at the moment?
I think we have technologies installed in our facilities already that are underused. Most of the facilities has a BMS system.
Yeah.
And BMS, if maintained correctly, it is really a great source of data.
Yeah.
But it's underutilized. What we are depending BMS on is only alarms. So there is an alarm that came in and then we go and see it. But actually the amount of information that can come from a building management system is massive and it's good for planning. What is underutilized is some technologies that can make, as you said, the life of the technicians easier and they love their job more. There are tools that like the virtual reality tools, and I see it very interesting tools for maintenance because now if a technician goes to maintain an equipment and he doesn't really know what's the issue, the first thing he does that he calls the supervisor and he starts explaining the issue to the supervisors and he starts receiving the information from the supervisor trying to fix the issue. Now with the AI involved and all these VR technologies are available, if there is really a key issue that I can learn how to fix it myself by having some sort of a digital twin image of that equipment, the critical equipments, let's say, it's brilliant. It's really amazing. It can save downtime. It can be performed in a safe manner for the technician who is doing it or the group of people who are doing it. And it's a learning tool for that person. So the next time that this person faces a similar situation, he's done it himself.
Yeah. And overhyped? Are there certain technologies overhyped at the moment?
Nothing I can think of, to be honest, at the moment.
No.
I'm sure there is, but I cannot recall it.
No, I think neither can I, by the way, immediately come up with something that is overhyped. I think certain things are yet to be seen how, not if, but how they will impact our life going forward.
I mean, everybody's talking about AI.
Yeah.
And to be frank, whether we like it or not, AI is coming.
Yeah.
For most of the industries. It's how we can benefit from it for the benefit of the business, the benefit of the people, the benefit of the equipment is the trick there.
Yeah.
And that needs also, again, an open mind for people to adopt these technologies. You can tell that from the speed that it's growing and how, I mean, when ChatGPT came in, I was hesitant to use it. I'm using it now in a smart way, of course, but definitely it's making my life easier in some sort of aspect. So there is no issue I see in adopting it in the right way.
No, and that is for sure. I mean, some of these technologies actually help us maybe refocus on some of the technology we already have in-house, because if you talk about BMS, indeed, I don't think many organizations use it to the fullest extent that they could. And of course, that's a big investment companies have made in the past, and you should. When you look globally, we benchmark ourselves a lot to the global environment, other parts of the world. What do you think actually the world could learn from our region, from the Middle East? Because we have this beautiful opportunity to leapfrog, basically, so now and then. Are there certain things that the world should look at the Middle East for and say, hey?
There is definitely. I mean, look, the interesting thing about our region is the courage to try new things. So organizations are willing to invest in technologies or in new business models that are, I wouldn't say tried widely across the world yet, and learn from it and sometimes give feedback to improve it. I believe in certain parts of our region, we now have our own standard of doing things in terms of quality, in terms of results, in terms of knowledge even. You can compare it in different aspects. I mean, even if you look at the way that a city is cleaned compared to other regions in the world, there is nothing like that. The way that the buildings are maintained, most of them in the building are maintained in an excellent way compared to the world. And the most important thing that I see that is really a key learning in our region to the world is the way that things are regulated. So if I'm a customer living in a building that is sold by the client, 100% sold, I still can ask for maintaining it properly because of the shared ownership law that we have in the region. Many aspects can be taught to the world.
Yeah, and I think we are operating ultimately in an extremely difficult, harsh climate. So that in itself is also learning how do you do it when in the summer months, basically the temperature shoots up to 50 degrees Celsius. And that's a tough one to operate in. Lots of wear and tear, obviously, on equipment, buildings, etc. Now, you have a rich career. You've done lots of different things. You teach also. What was sort of for you the most pivotal moment in your journey where you said, that has formed me and my outlook of how facilities management, sustainability, energy conservation, all of it comes together? Was there a moment or multiple moments?
Well, there were very important moment when I started my career as a mechanical designer for building systems. And that was very important for me to understand how to design things and how things work. And I stayed in that career for around maybe 8 years. And then I moved to, or actually a little more, then I moved to operation. At that moment, when I entered the operation industry, facility management at that time, I looked at it from a different perspective compared to normal facility management because I have some sort of knowledge about how these things operate, how these equipment operate, and why it was designed in this way. And then how we can make it better by changing the design or maybe the operating parameters. So that was the first point. The second one, I consider myself a lucky person that across my career, I worked in organizations that were really supportive to me. So I had a shift in facility management to energy management as well for a few years. And that added to the, I would say, in my knowledge and experience. When I finished, when I got, I say 3 or 4 years of experience, that incident of the car happened.
Okay.
And I was able to put all these together at that point of time to come up with a new regime that I see should be the best practice. And it's been one of the things that I really like doing every couple of months is to search online about energy-centered maintenance and to see how it is growing globally. And it's interesting how things are grown over the past 10 years. And sorry, I want to say something that's maybe not related to me, but it's related to the people who read or attend some of my seminars. Many things improved in my knowledge and my personality and even the book itself by feedback from people. And there are things that I never thought of. Somebody asked me a simple question about it. Like a person asked me about cybersecurity when you implement AI-driven energy-centered maintenance. So that was an interesting question that I didn't think about it myself. But when I thought about the situation, you see that there is a subject matter expert who's experienced in a certain part that touch base on the AI-driven energy-centered maintenance, who asked a question that makes a huge difference. So there is a lot of feedback that I'm receiving that really makes things better.
Yeah, and it is ultimately it's a growing topic, not just here, globally. So there will be indeed also lots and lots of new angles coming to light. I mean, AI, machine learning brings a lot of that data. When you collect data, what is happening with the data? How is it being protected? Also, quite an important one. So, what does it mean for you in your day-to-day job, your private life, maybe, to have a green mind?
Oh, wow.
It's a big question, I know.
It is big. I would say the very first thing is to have an open mind. Sustainability or green supporting initiatives is not a single person effort, and it will never be. That there will be a green hero. This person works with different stakeholders, and these stakeholders can be either internal within the organization or external. It could be departments like finance, human resources, technical department, facility management department, and others. And also it touch base on end users, residents, people. So that particular person, to have a green mind, he needs to be really open-minded and be able to bring all these people together around the same objective.
Yeah. It is more than just changing the light bulb. It is a lot more than that. Yeah. Fadi, thank you very much for this conversation. It was a pleasure.
Thank you so much, Walewein, for having me. Thank you.
Thank you.